Hello, welcome to lesson 5. I'm going to start this one where I left off on the barcode, the bar graph, the potentiometer controlling the bar graph on the Arduino. And I'm running the exact same code, and I'm going to take it and wire it to this analog input, the CDS cell or the photo cell. And we're going to use that to control my graph and make a light meter out of it. So a potentiometer has 3 wires, top one, bottom one. Across it is a resistance that never changes. The middle one is the wiper, which varies the resistance. This only has 2 sides. I labeled them T1 and T2. There's only 2 wires coming off this. So we're going to do a slightly different hookup on here. And what I'm going to do is I'm going to take the positive wire and I'm just going to hook that to one of my terminals. I will choose T2, it's on the top. So I'm going to hook positive to there. I'm going to take my wiper wire, which was in the middle of the potentiometer, and put that on the other side, the T1 connectors. And then what I need to do is I'm going to take this ground wire and I'm going to jump it through a resistor. So I'm going to choose the 10K. You can use different values on here. 10K seems to work the best, and it just kind of changes the range of output that you get from your photo cell. And the other side of the 10K resistor, I'm going to plug in here and jump that down to the T2 connector. This is also the one where the analog pin goes to. I'm sorry, T1 connector at the bottom of your photo cell. So I have it there. You can see as I make this darker, I got a lot of light in the room, I get a little bit of variance in my light meter. As it goes darker, it goes up. I guess this is a dark meter because it's operating the opposite direction I want to do. Changing the direction of the wires won't make any difference. So what I'm going to do is I'm going to go back to my code and see if I can get it to operate backwards. So I'm going to look down here where I have this patient says right in here on line 20. By the way, the line numbers are right down here in the corner. Line 20, it says to reverse the direction which the LEDs are selected. Well, let me try changing that. I'm going to comment line 20 and oops, wrong direction. Backslash and uncomment line 19. And let me recall what that did. I think this is going to make it light up from the top though, instead of the bottom. And yep, it lights up from the top. Still a dark meter instead of a light meter. And you notice we don't have a lot of range on there as well. So tell you what, let me put this back the way it was. So comment line 20, comment line 19, uncomment line 20, and let's go down and find out what our range of values is. Here's what I'm going to do. I'm going to open up the serial monitor, and oh wow, that's going really fast. Looks like I'm in the 900 range when it's bright. And let's just say darkness is in about the 640 range. Okay, I can also slow that down by putting a delay in there. So what I'm going to do is go down to my map line and change my range that I'm looking for. And that was right down here, analog value. And I forgot what I just said for my values. I'm going to open up, this is why it's helpful to have that little monitor. You can see what the computer's doing. Looks like about 920 when it's bright, 640 when it's dark. So let me do this. I'm going to change my range from 640 to 920. Okay, and that's going to take your analog value that we're reading and take this range from 640 to 920 and up it from 10 to 0. And I think that's where I'm going to need to change my 0 to 10 to get it to go in the opposite direction, so it'll be a light meter instead of a dark meter. I'm going to upload my code. and test this circuit. Oh, there we go. Now we're getting a nice full range. I could probably get the 10th one if I go a little bit darker, but this is officially a dark meter. So let me change the 10 and the 0 around, because these two numbers here, I think will reverse the direction. So I'm going to put a 0 here and a 10 here, and this is how I'm going to leave the code uploaded on the site. So assuming this works, I'll leave it like this. And this should give you an analog value for a light meter. Super bright. As it goes darker, yep, so now it's sensing the amount of light in a room. Now you could have these levels be a trigger threshold for something. If it gets to this level, brightness 5 or 8 or 10 or whatever, it'll sound an alarm. Or it'll do something, it'll turn on a motor or make something activate. So you can use this to measure the light reading in a room. You could have it by a window and it would measure how much sun there is, cloudy days. You could have it do data logging and track, how much sun is coming in the windows, what time did the sun rise, clouds, and do some data extraction. So the way I have this all wired is all of my LEDs, I have the negative side all hooked together. One jumps from the one to the one to the one to the next to the next. That goes into the ground part. Every LED, starting on the top one, goes to pin 2, and then pin 3, and pin 4, and pin 5, and pin 6 on the Arduino. So I have all 10 of these hooked up from 2 to 11. And once again, the photocell, I have hooked up the T2 post. The top two connectors are the same. Labeled T2, I have that hooked to the positive. And on the bottom, I have it hooked to analog 0, and also I come from there to the 10K resistor. The other side of the 10K resistor goes back to ground on the Arduino processor. So this will give you a light meter. It is taking an analog value, which in my current lighting situation, you can see these. Oops, lost my serial monitor. It's gone. I hate it when that happens. It was going from 650 something to 900, and that's what's giving me my range of values. So what I anticipate for doing for the next lesson is I'm going to switch from reading an analog sensor. Both the potentiometer and this photocell are analog sensors. They basically give you back a voltage reading. You can also use this to check batteries. I might do that in the future. I'll make you a battery tester so you can test your batteries. But I'm interested in working with this little guy right here. This is a infrared receiver. All of your little remote controls for your TV work off this. And this doesn't give an analog signal, it gives a digital signal. It actually sends data back. So I want to do a little experiment and make a little project for that to actually repeat and send out an infrared signal that it receives. So I'm going to start working on a lesson for that, and that's what I'll see you next time. If you have any questions, please post your questions. Let me know how it turns out, and hope to hear from you soon. Bye-bye.